Okay, so we're now going to be talking about probability. So you had an introduction to probability 2 days ago. So it says here, you've often heard the statement such as the probability of rain tomorrow is 60%, or my team stands an 85% chance of winning their game. These are probability statements. You know intuitively what probability is. We're going to figure out the calculations behind it. So we have started with some basic examples 2 days ago. Now we're going to apply the counting principle. In general, probability is the number of ways an event can occur in a specific way divided by the total number of ways that it can occur. So this is your probability formula. The number of outcomes of the events of interest divided by the number of possible outcomes. So the probability here, again, they represent, so this is the probability of an event. You don't have to write A, you can be specific and talk about what it's actually, what you're trying to find. Your NA is represented here by the desired outcomes that you want. Your NS is the total probability, or all of the options that you have. David, did you get a late slip? Did you get a late slip? You gotta go get one. Yep, it's past 8:30. Pardon? You're present. Yeah, you gotta go down in the office, sweetie. Okay, so it says here, what is the probability of drawing an ace from a standard deck of cards? So again, I've given you that cheat sheet with your cards. So if I want to find the probability of this event happening, I'm going to write here the probability of drawing an ace is equal to, okay, how many aces are there in a standard deck? 4. How many cards are there in a standard deck? 52. So when I do this, I can reduce it into lowest fractions, 1 over 13, which is another way of saying 0.0769. And then so that's saying that there is a 7.69% chance that you are going to draw an ace out of a deck of cards. Okay, does anyone have any questions with that example? All right, just a little note here. The probability of an event happening can never be bigger than the total number of events. The probability has to either be between 0 and 100%. You can never be 110% or 101%. So it now says here, there are a bag of poker chips with 10 red chips, 12 blue chips, and 8 white chips. What is the probability of selecting a red chip? Joanna, what do you think you would write for this? Good. So I would have here the event that I want, your NA is red chips. There are 10 red chips. Your NS is the number of total possibilities, 10 plus 12 plus 8, which gives me 30. I'm just writing this out so you can see this. So the probability of getting a red poker chip is exactly what Joanna said, 10 over 30. What is that into a reduced fraction, Johnny? One over 3, which again gives you 0.3333. I'm always rounding, I'm keeping 4 decimal places. That's what I would like you to do, which is saying that there's a 33.33% chance of you picking a red chip. Okay, what is the probability of not selecting a red chip? Okay, there's two ways to do this. This is another way of saying the complementary, which I talked about on Monday. So again, the complementary is saying like this, the probability of A prime, which is another way of saying 1 minus the probability of A actually occurring. So in this case here, A represents drawing a red chip, A prime represents not drawing a red chip. So if I look here, the probability of not red, what do you think I would write for that? Dylan, can you help me out if I'm doing 1 minus the probability of A? Yep, 1 minus 1/3. Yep, which gives us 2/3. And when I calculate the decimal of that, there's a 0.6667. So there's a 66.67% chance that you are not going to select a red chip. Does anyone have any questions about what I've done so far? Okay, it says here, these two examples are examples of theoretical probability. We didn't do any experiments. We just assumed that it would work. This is realistic in situations where the outcomes are well understood and precise. There is no reason why drawing one card or picking one red chip would be more or less likely than the other. Sometimes determining our NA and NS are not as straightforward as the above examples. Sometimes we have to use our counting principles from the previous unit. So here's it. We're now going to be discussing tree diagrams. When flipping 3 coins, what is the probability of getting exactly 2 heads? Okay, so I know that yours is small, so you're definitely going to want to write small. I'm going to do 3 tiers of this. The first coin that I can flip can give me a head or a tails. The second coin that I can get a head or a tail, a head or a tail. Are you with me so far? The third coin I can flip gives me a head, tails, head, tails, head, tails, a head or a tails. Those are all the possible outcomes that I can have when I'm flipping 3 coins. So my options are, if I write them out and I follow each of the tree diagrams, so I'm going to follow each one of the branches, I can have one option of going heads, heads, and heads. So that's one option. So I'm just going to write it out here so I can have a head, and another one. Noah, following in the same order, what would be my next option? Yep. So I can have a head, and a tail. So that was Noah taking care of this one. A head, and the tails. Spencer, can you give me another one? Heads, tails, heads. Thank you. And if you give me another one, Scott? Heads, tails, tails. So we've just taken care of this branch and this branch here. Yeah, I'm just writing out all of these. So you're right. I'm not answering the question yet. Powell, can you give me another one, please? Tails, head, head. David, give me another one. Tails, head, tails. Billy, another one. tails, tails, head, and Pat, the last one. Tails, tails, tails. So are we all okay on how to read a tree diagram and come up with these? If you flip 3 coins, you will get one of these 1, 2, 3, 4, 5, 6, 7, 8 options. So my NS is going to be 8 because there are 8 combinations. You can get that. Do you have to write out all of these heads, tails, heads? No, you don't, but I wanted to make sure that you knew how to read the tree diagram. To get your NS from your tree diagram would be just counting all of these at the bottom, your last branch. 1, 2, 3, 4, 5, 6, 7, 8. Now, I want the probability of getting exactly 2 heads. Natalie, how many ways are there to get exactly 2 heads? Okay, there's 3. I know that this heads, heads is not 1. My next one here, I have 2 heads. I have 2 heads. I don't, I do, don't. So my NA is equal to 3. So my probability of getting 2 heads is equal to 3 over 8, which gives me a 0.375, which is a 37.5% chance that when you flip 3 coins that you will get 2 heads, exactly 2 heads. Okay, does anyone have any questions about this example? Okay, the permutation example. In a horse race with 8 horses, what is the probability of you picking the correct ones to finish first, second, and third? Okay, so again, I'm going to be looking at the number of total possibilities. So there are 8 horses. I have 3 spots, first, second, third. How many, what would I fill into that first blank? Mike? 8. And then once I have 8 options for first place. Michaela, what would I put for the next one? 7 and then 6. These are my total possibilities for first, second, and third. So my NS is 336. Now, we're having a horse race. My NA, how many ways would there be a first place finish? Joanna? 1. And then second place, Joanna? Not 2. You don't have 2 second place finishers. We have 1 and then 1. So there's only, when you race, you have first, second, third. That's it. And we want to correctly pick who's getting in first, who's getting in second, and who's getting in third. So the probability, there's only one way to guess correctly who's going to win. Natalie, you got to stop talking. So the probability of event A, so I won't write it out, we can keep it general, is 1 over 336. When I calculate that as a decimal, it gives me 0.0030. There is less than 0.5%. You have a 0.3% chance of getting the first, second, and third place. When you do the horse racing, when you do gambling odds, the odds are never in your favor. The whole purpose to Gambling is that the government kind of wants to take your money. So the odds are never in your favor. Some people get lucky, but the probability that you actually win, if you were guessing the first, second, third place, you have less than 1% chance. Okay, so the next one here, it says there are 3 people in a line at the grocery store. Gentlemen? Sorry? There are, you're right, but there are 335 ways to get it wrong and 1 way to get it right. So the odds are that you are going to get it wrong. There is a chance. You don't have a good chance. Yep. Who won the Kentucky Derby? I forget what the night. Yeah. Yep. Okay. So there are 3 people in line at the grocery store. What is the probability that the oldest person is at the front of the line and the youngest person is at the end of the line? So again, here I have 3 people who are in line. If I want my total, what are the total ways that I can have people? What would I write in for that? Ben, can you help me out? Mm-hmm. I want to figure out how many possibilities. What's going to be my denominator here? Okay, so how many options do I have for my first? No. No. I'm not figuring out the event that I'd like. I'm figuring out the total, my denominator. So, and then the next one, and then the next one, 1. So this is another way of saying 3 factorial, which gives you there are a total of 6 ways 3 people can be arranged. Now, I specifically want the probability of this event. So again, I have 3 people in line. I definitely want my oldest person here and my youngest person here, which means how many ways can I do this, Johnny? There's 1 way. The oldest person has to be at the front, the youngest person has to be at the back. There's only 3 positions, so the middle one has to be in the middle. So my probability of this event occurring, Dylan, what would I write here? 1/6. What is that as a decimal, Noah? If we round to 4 decimal places, it should be 1667, which is 16.67%. Okay, the next one here, the combination example. So again, we're tying in what we did in the last unit into this, into now calculating the probability. So it says here, 3 students need to be chosen out of 20 volunteers to help with the results at the swim meet. If there are 12 girls and 8 boys volunteering, what is the probability that the students chosen will, for the results, will be all girls? Okay, so it's saying I have 20 volunteers to help out. There are 12 girls, 8 boys volunteering. What is the probability that the students will be all girls? So when I look here for my total, how many options are there? I have 20 students and I need 3 of those students to volunteer. So, Spencer, what do you think I would write for my total outcomes? Very good. 20, choose 3, which gives me what, Scott? 1,140. Now when I look at, okay, what is my desired result here? My desired result is that there will be all girls. So, Powell, what will I write for all girls? Okay, I want 12, choose 3. And I mean, you can write this 8, choose 0, because you're choosing 0 boys. It just gives you 1 anyway. Do you have to include the 8, choose 0? No. So when I do this math, David, what do I get? Good. So when I want the probability of all girls, Billy, what will I write? Very good, which gives me what as an answer, Pat? (11/57), and as a decimal, Natalie? I think if you round it, it's 0.1930, which is 19.3%. Okay, our last one here, this is again a bit tricky. So it's kind of all building. Okay, in a raffle, there are 25 tickets sold. You bought 4 of them. There are exactly 3 prizes being given away. What is the probability that you will win one of the prizes? One of the prizes. Okay, what do you think we're going to do about this? One of the prizes. This is a bit unique because I have to look at all different cases. I have exactly three prizes. So I'm going to write prize 1, prize 2, prize 3. I only want to win one of them. So what I can do here is I can win the first prize, lose the second, lose the third. Or, because they're specific prizes, I could lose the first, win the second, lose the third. Or I could lose the first, lose the second, win the third. There are 3 ways that I could win exactly one of those prizes. So when I look at this, if I'm calculating the probability of winning one of the prizes, I'm going to look at my first case. Okay, how many ways can I win? What is the probability of me winning? Natalie, can you help me out? Mike, can you help me out? Can you help me out? They're in a raffle. There are 25 tickets sold. You bought 4 of them. What's the probability of me winning prize 1? How many tickets were sold? Okay, so I know there's 25. How many tickets do I own? 4. I have a 4 out of 25. The odds are that, there's 4. I bought 4 tickets. There's 25. That's how many ways I'm going to win. Now, in order to lose, so that's me winning the first prize. If now I'm losing the second, Michaela, what do you think I'm going to write for the probability of the second? Not over 25 because the first prize is already gone. 24. And Joanna, if I lose the third prize, what do I get? Mm-hmm. So that's the number of ways to lose. Okay, we're talking about you have tickets in your hand. You have 4 tickets in your hand. So you won the first one. You lost the second one. So how many losing tickets are out there? And you have 3 still in your hand. You have 3 tickets in your hand right now because you already won one, right? No, I still have 3 tickets in my hand. If I lost the second one, I still have 3 tickets. My 3 tickets are still in the draw. I want to lose. How many ways are there to lose? $20. Okay, now because there you can do this, what we would do here is we would then take this answer and we would times it by 3 because of these 3 cases up here. You will see that the probability of all 3 of them are actually the same. The numbers, this piece here is kind of just flip-flopped. This is difficult. You have to do your homework. You have to practice this in order to understand kind of what's going on. So again, there's 3 ways. So you have to look here. There are 3 ways, there's 3 ways you can win exactly one prize. Win, win, win. This is the example of winning on the first one. So if I'm doing my second case there, what is the probability of me losing that first draw? What would I write in that second line? I have 4 tickets in my hand at the beginning. There are 25 tickets in total. I want to lose. How many ways can I lose? How many tickets did you buy? 4. That's prize 1, prize 2, prize 3. Right. You bought 4 tickets. Yep. What do you mean? Yep. Yep. Or okay, so you have 25 tickets. So everybody here puts their name in a draw. Yep. Because I'm telling you, we're calculating the probability of that. So there's 4 tickets in there. When you pulling out any random ticket, it could be one of your 4. You have 4 ways to win that prize. Doesn't matter which prize. They're just drawing it consecutive. Yeah, because you're losing this. Right. Okay, so for this one here, you don't have 21 of the tickets that, exactly what Ben said. One of these 21 tickets are going to be picked that you don't have. Times, pardon? So the first one, so in this case here, if I'm losing first, it's the first draw, so there's 25 tickets altogether. Then if I do the second case here, if I win, well then it becomes, I have 4 tickets that could win over, first prize is already taken care of, it would be 24 here. Times my third way I have to lose, well, it would now be 20 over 23. It's these 3 numbers on the numerator and these 3 numbers in the denominator. You don't have to go through each case. What you can do is, again, just multiply by 3. You still get the same answer each time because we're adding each one of those cases. Your third case here for lose, lose, lose will be 21 over 25 times 20 over 24 times 4 over 23. They're all the same numbers when you multiply. So it's like saying or. So we add them, which is why we just put the multiply by 3, because I have those 3 cases. When you do that, the probability of this event occurring is saying a 0.3652 chance, which is 36.52%. Okay, the last example. Does anyone have any questions about one of the prizes? The last example, what is the probability that you would win exactly all 3 of the prizes? So that's like saying prize 1, prize 2, prize 3. I want to win, and win. So what am I going to write when I want the probability of me winning the first prize? What would I write for this? Johnny, can you help me out? Okay. No, how many tickets do you have? 4 out of 25 for the first win. My second prize, David, what do you think I would write for that? Yep. And the next prize, Dylan? Very good. And when you do this math, you would get 1 over 575, which gives you, when you do that, you'll get a scientific notation of 1.7391 times 10 to the exponent -3. And then when we multiply that by 100, you will get 0.1739%. Okay, so if you are sitting here and you are saying, I don't understand this, this is over my head, you have to practice your questions, actually genuinely try them, and then ask me for help tomorrow. If you're not doing your homework again, you're going to get crushed.